Lesson 8-6, we are talking about inequalities today. So the essential question says, how is an inequality like and unlike an equation? Well, we know what equations are. They have equal signs. And so today we'll learn about inequalities. An inequality compares quantities that are not equal. And these are the signs that you used back in elementary school. You have less than, greater than, less than or equal to, and greater than or equal to. Those are the four signs. For more information on those signs, let's take a look at this chart. We have the less than. Here's what it means, less than. And then we have this closed and open circle idea. Now this is new for you, I believe, and we want to make sure we know how to use it. So it says closed and open circles. When you use a less than or even a greater than sign, you're using an open circle. When you're using a less than or equal to sign, or a greater than or equal to sign, right here, you're using a closed circle. And the idea of this is on a number line from very long time ago in elementary school, when you had a number 2 and you wanted to graph it from your elementary school teachers, you would put a circle on it and say it's number 2, and that would be x is 2. So if something is the number, then it is colored in saying yes, this is the number. However, if you have a number that is open like this, it's beginning at 3, but it does not include 3. We'll talk more about that here in just a little bit. So coming down to your next part of your notes, this is a nice number line, and it's saying that it starts at 2 and is open circle, but it does not include 2. So it says x is anything less than 2, and you can see this big thick bar down here. Anything that is lower than 2 is good to go. So here's some examples. 1 is less than 2, 0 is less than 2, -1 is less than 2, and you can even go as close to 2 as possible, but without saying it's 2. Possibly like something simple, 1 and 9/10, or 1 and 99 hundredths, or 1 and 99 hundred thousandths. Anything that is less than 2 is good to go. But in this, when it's open, it's not 2. It's just anything less than 2. The next one's just like it, but the arrow is on the opposite side. And examples would be 3, 4, or something really close like 2 and 2/10, but it does not include 2. And this means x is greater than 2, meaning x is anything more than 2. The next one you can now see the closed dot here, and that means anything less than 2, and we include one more answer, which is 2. So x is less than or equal to 2, meaning x is anything less than or equal to 2. And then you can see the last example is just the opposite. It's anything more than 2, and it also includes 2. So x is greater than or equal to 2, meaning x is anything more than or equal to 2. So knowing that, let's go down and practice these examples. On number 1, the number that we are talking about here is 5. And so we're going to naturally use an x as our number, and then we're going to write 5 here. And now we have to determine what kind of inequality sign are we going to use. It is an open circle, and that means that this branch right here is anything greater than 5, but does not include 5. So we will use the greater than sign. X is greater than 5. Let's try another one. Number 2. This one's closed. So on this one, we can see that it's less than -5 or even negative 5. So we're going to use the variable again, x. We'll use negative 5. And it is less than, but it's also, since it's colored in, also equal to. Number 3. This one we need to draw it. So go to about the center of the number line, make a circle, call it number 10, and now we have to determine which way the arrow is going to go. X is greater. Greater is to the right. So here's some different styles you can use. You can color it in thick like this, like you've been seeing, or you can go straight up and over, kind of like a 90-degree turn, or I've seen other styles just kind of curving out over the top of the number line. You're going to typically see me do the curve model, but all of those mean the same thing. Now this says x is greater than 10, and so all of my arrows are going to the right. I am not coloring in the circle, the point, because it does not include 10. On number 4, we have x is less than or equal to 10. So again, I go about to the middle, and I can call this 10. I'll circle it, put a point there. And now it does say that x is less than. So anything less than would be in this direction, or I could say it like this, or I can even do a thick line like this. All right, now it says or equal to, so my bubble is not correct, because 10 is also included, so if I want to include it, I'm going to shade it in, just like this solid line here. And number 5. X is greater than or equal to negative 2. So I can choose any of these lines to call negative 2. I've been typically choosing the middle one, but you can go anywhere really. Circle something, call it negative 2, and x is greater than, so it's going to go to the right. It says or equal to, so we're going to color this in. And the last one, pick any spot here. I'll choose this one, call it negative 5, and x is less than. So we're going to go to the less than side. If you get confused, to the left is less, and to the right is greater. Now this one doesn't get colored in because it does not include negative 5. Number 7, for the given inequality, state whether each inequality is true or false. So this looks a little bit confusing right now. Here is the inequality, and they're asking you what if s is 6, and that takes you back to the substitution property. So you got to use parentheses, and you substitute 6 in for s. So you put the 6 here, and then I would use additive inverse here, and 6 plus negative 9 is negative 3. Is negative 3 less than 4? Yes, so we say it's true. So we'll go over to number 8, and it's done the same way. The problem is right here, and we're substituting in 36 for a. So we'll build our equation, or our inequality. 14 is less than or equal to, parentheses on top, divided by 3, plus 1. And on the top we put 36. And then we use our gems here. 36 divided by 3 is 12. And 12 plus 1 is 13. So we bring down everything, and then we look. Is 14 less than or equal to 13? It's not. So this is false. Remember to always put your first name, last name, date, and period. And let's jump down into these. Let's do some odds. Write an inequality for each sentence. Number 1, to pass his math class, Manuel needs to earn a grade of at least 70%. So we're going to be careful when we do this. His grade needs to be at least 70%. So we're going to do x. His grade needs to be at least that, so it can be 70%, so or equal to, or greater than 70%. So he wants at least a 70. So he'll take the 70 or he'll take anything higher. If you look at number 3, to train for the upcoming marathon race, Jeff must run at least 30 miles each week. So that would be X, and the minimum is 30, so he'll take the 30 or equal to. Number 5, a cell phone bill increased by $10 is now more than $60 per month. So a cell phone bill increased by 10. So we don't know the bill. It is now X is increased by 10 is now more than. This side over here is more than $60 per month. We jump down into the odds down here. It says for the given values, state whether the inequality is true or false. Now I gave you some good examples in the notes on how to do this. Just being careful that you're using the substitution property and you're subbing in X as 7 in here. Make sure you use your parentheses. Put a 7 there, and that's 14 minus 4, and that is 10. Is 16 less than 10? It's not, so this is a false statement. And then finally, the last set of directions says graph each inequality on a number line. So that's, you're just going to go and say X is greater than -3, so you shop for -3, you circle it, then you determine if you colored in or not, and then this one is an open point, so we leave it open, and X is greater, so we're going to go to the right. And you can finish off the odds and evens.